Wouldn't it be cool if there was a lab that could take soldier problem sets and come up with creative solutions and really make soldier dreams a reality?
U.S. Army Video and Graphics by Bianca Laffin.
So the USARCENT Innovation Manufacturing Center was created as an approach for USARCENT to push forward innovation, production through advanced manufacturing at the point of tactical need. So this hub that we've established here at Camp Arifjan serves as the connective tissue from USARCENT and the soldiers that we support, those task forces, OIR, Task Force Spartan, all the troops in contact that really need responsive and agile production through advanced manufacturing to meet their material readiness needs forward. This hub serves to support multiple spoke locations up in the OIR area of responsibility at Erbil Air Base, H5 in Jordan, down to PSAB in the Kingdom of Saudi Arabia. All of the different locations where we've got major operations going. We have several partners that we work with in both the Army and the Department of Defense advanced manufacturing ecosystem. First and foremost among those is probably Army Material Command's Tank and Automotive Command. TACOM's responsible, and they are the Army's lead executive agent for providing through the Joint Manufacturing Technology Center at Rock Island Arsenal, the digital repository, wherein we have all of the technical data packages for those parts that we're able to produce through advanced manufacturing. Working with the original equipment manufacturers, we take their technical data and then either through reverse engineering or by taking those specs that we get from the OEM, we're able to create with our connective tissue between the USARCENT Innovation Manufacturing Center and the Joint Manufacturing Technology Center. Drawing upon that digital repository, we're able to download those files, create those parts through advanced manufacturing here for soldiers, or through reverse engineering, taking an innovation case from soldiers' recommendations in the field. We're able to, through computer-aided design, drafting, we're able to create prototypes for those using polymer advanced manufacturing, then putting it in the right type of material, everything from carbon to, as I said, polymer for prototyping, all the way up to high-grade steel or titanium, depending on what the use case is.
All of USARCENT subordinate units, all of CENTCOM Army units can provide soldier input with problem sets, and they can also volunteer here at the lab and provide that manpower. Other key stakeholders are DevCom, Futures Command, and also CMI2, our civilian contractor partnership, the Civil Military Innovation Institute.
We think that at the AIMC, we can really pursue several lines of effort. And so when we talk about the USARCENT Innovation Manufacturing Center, we're really looking at proceeding along three lines of efforts: manufacturing, innovation, and training. And really what that comes down to is looking at the capacity that's provided at the AIMC, which is really built around the nucleus of the MWMSS, or the Metalworking Manufacturing Shop Sets, Type 1 and Type 2. We've added around that several additional pieces of technology, everything from high-end laser etching, MIG and TIG welding, plasma cutting, the ability to prototype with polymer on 3D printers. We can also create utilization of additional large hand tool sets to do advanced welding and cutting applications. So through the manufacturing line of effort, we have the hardware and really get after putting their skills to use, creating, as I said, from that digital repository from the Joint Manufacturing Technology Center, creating those parts that are already in the catalog, or creating new ones based on use cases and our innovation test cases here in theater.
Here at the AIMC, we have the unique capability where we can manufacture Class 2 and Class 9 parts in small batches. Also, we can do operational projects such as ramps, welding equipment together, and other operational pieces that don't exist in the Army. We can manufacture those here as well.
So the manufacturing capabilities that the AIM Center provides on our other part of the lab is going to be starting off with the lathe machine. It is able to make cylindrical cuts out of solid aluminum and other metal pieces. The next piece is the CNC machine, which is able to do a three-dimensional cut out of any type of material. Both of those pieces are part of a system called the MWSS. Additional pieces to that is going to be your welding and cutting capabilities. Starting with welding, we got TIG, MIG, and stick, which are your three key elements of welding. Moving on to the cutting capabilities, they have an oxyacetylene torch, a Broco, a plasma cutter handheld, and 4x4 foot table. On that side, additionally, we have some of the innovation equipment because it does involve metal as well, and we like to consolidate. So with that, we have a 8x4 plasma cutting table and a CNC machine, as well as another welding machine to be able to help provide lateral capabilities.
When a customer comes in with an idea, we do our best to get that idea on paper. Once that idea is on paper, we figure out which process we need to use to manufacture that part, that being CNC mill, CNC lathe, or welding. And once we figure out our process, we then utilize that process to manufacture that part.
A lot of times customers come in with some type of widget that's broken, and we can simply weld it back together for an expedient repair to save downtime on equipment. But then another solution is this part here. We didn't have this exact angle iron here in the theater, so we were able to make it ourselves by flat stock and then just welding it together in a couple places to get that exact dimensions to meet that need for that customer.
That manufacturing line of effort then lends itself naturally to the innovation line of effort, where we have 3D imaging. We also have polymer prototyping, where we can take, for the new use cases, those suggestions from the field and create, through computer-aided drafting and design, our own technical specifications that we then create models for and put them through some initial use in a non-tactical situation, and then we put it into effect in the field in conjunction with TACOM's technical bulletin on battle damage, repair, and fabrication. The TACOM commander has proofed a series of parts in conjunction with the original equipment manufacturers and has underwritten to a certain degree of risk what we're able to use here forward in theater. So if you think about the digital repository, we have several hundred parts that are already in the JMTC digital repository. Those we're able to have a connection with from the AIM-C back to the digital repository. We can call forward those technical data packages and quickly produce those in theater, or again, taking innovative test cases from the field, we're able to reverse engineer and create our own set of specs that we send back to TACOM. What this allows for us is to generate, at the tactical point of need, a material solution. Sometimes the supply chains may have parts from our OEMs on back order for a number of days to weeks, perhaps even months. As you know, the op tempo that we're supporting here in CENTCOM can't afford to wait for weeks or months for a part. So by creating a temporary part here in accordance with the TACOM technical bulletin, we can apply that part, and then when the supply chain provides the OEM part, we take off the advanced manufacturing part, send it back to TACOM, they can do their analysis on it, and then in conjunction with the OEM, make the determination if what we've created forward meets all the technical specifications. So we're really looking at being able to quickly produce a part here in theater and then reduce risk to our service members and risk to the operation by not having that delay and waiting on a part from the supply chain.
The Innovation Lab, at least in this section of the lab, is meant to take ideas that soldiers have from problems that they can see when they're working and make solutions for it. The thing printing behind me is a semi-dome that's meant to protect some equipment that doesn't have that ability on its own.
So this piece is a frame that fits over a satellite, and this frame will be skinned in like textile material, and it'll really keep debris, sand, wind kind of elements off of that satellite, keeping it up and operational. And so that piece can be 3D printed fairly quickly, and we can skin that in textiles fairly quickly and really keep a key and critical asset up and running. And that piece was dreamed up by a soldier within about 3 days. We did a prototype test fit and had a design flaw. We corrected that design flaw, and within a week we had that 3D printed frame out.